Again back to solve this problem. So this is the problem of the day, and I make a live attempt to solve this problem. So I haven't read this problem before. I'll be solving this in front of you guys. I'll be building the solution from scratch, and let's see how can we approach problems in an efficient way. So yeah, this is the third day of the live stream, and basically today is the third problem. And let's quickly jump to the problem and let's start it. All right, so we have this question given here, which is remove subfolders from the file system. Let's read aloud. So given a list of folders folder, return the folders after removing all subfolders in those folders. So you will be given a list of folders, okay, which is folder, and you have to remove all the subfolders in these folders, okay. You may return the answer in any order, okay. So by now I could not get much clarity, so we have to remove all subfolders and we can return the answer in any order. Okay, let's read ahead. So if a folder I is located within another folder, folder J, it is called a subfolder of it. A subfolder of folder J must start with folder J followed by a slash. For example, slash A slash B slash A slash B is a subfolder of folder A, but slash B is not a subfolder of slash B is not a subfolder of slash A slash B slash C. So slash B is not a subfolder of this, obviously. Okay, so the format of a path is one or more concatenated strings of the form slash followed by one or more lowercase English letters. Okay, so this is the format. So the format of path is like this. So there will be a string and it will start from this slash, and after each slash there will be one or more lowercase English letters. After that we can see one more slash, few more alphabets, like that. For example, this Leetcode, obviously it's a valid path, and Leetcode slash problems is also a valid path, while an empty string where you spot a slash and there is no character beyond this is not a valid string. All right, okay, so what we have to do, let's so we have been given a list of folders, which is this, okay, which is called folder, okay, and then you have to return the folders after removing all subfolders in those folder. Okay, so let me tell you how folder system works. We all are aware of it in our computer or in our something in a PC. It's kind of standard system. So there is a root, basically there is a root directory. I'll call this by this line, and let's say there is a folder named Leetcode, and under this folder, let's say we created one more folder which is problems, and under problems we created one more folder for the problem number. What is the problem number? 1233. So you see, problem 1233 is a subfolder of problems, right? And problems is a subfolder of Leetcode. Problem 123 is not a subfolder of Leetcode. It is just related to its parent, right? And the problems is related to Leetcode. That's what they meant to say over here. Let me just show you. So they told here, like, a subfolder of folder J must start with folder J followed by this slash. Alright, so for example, slash A slash B is a subfolder of slash A, obviously, because slash A is this, and then after that you have slash B. So slash B is a subfolder of slash A. Sorry, yeah, so this will be called slash A slash B. So it is a subfolder of slash A, right? But slash B is not a subfolder of slash A slash B slash C. What does that mean? Let's say slash A slash B and then there is slash C. So the path of this will be slash a slash b, the path of this will be slash a slash b slash c. So what are they are saying here is that slash b is basically this is not a subfolder of slash a slash b slash c. Obviously it is a subfolder of this folder is basically a children of it. Yeah, slash b is not a subfolder of this. Maybe I'm right. Now let's basically, if you are unsure about whether you have got the problem or not, you just pick an example test case and test your understanding of the problem. Okay, so we will be taking this example case 1. Let me use some other color. Okay, so we have been given this folders string and we have to remove the subfolders, right? So there is slash a, there is slash a slash b, and there is slash c slash d slash cde. So these are related to each other. Basically inside a we have folder b, and here inside cd, basically inside folder d, we have cde. And I hope these paths are absolute paths from the root directory. And then there is cf. So what does that mean? Let me draw this for you. So let's say this is the root directory, and here we have slash a. Just a second. Here we have slash a, inside that we have slash b, and then we have slash c, then we have slash d inside c, and then we have slash e inside d, and then we also have slash c slash f, right, like this. So what we have to do here is we have to remove all the subfolders in those folders. Okay, so what is the final answer? Final answer is slash a. It means we have removed this b, slash c slash d, slash c slash d. So slash c slash d was here, this is a subfolder of it, so this was also removed. And then we had slash c slash f, which is as it is. There is no subfolder of this folder, so we are safe. Let's check the another example. Here we have slash a, and inside slash a we have slash b, and we have slash c. So this is the architecture. I'm calling this architecture. We don't have all the folders given in the folder list, so I'll come to this very quickly. So there is slash a slash b slash c. There is also slash a slash b slash d. So there is slash a slash b, and then you come to this, it will be slash d. So the one thing which you must note over here is that, let me just make it a big broad one. So yeah, one thing which we must notice over here is that, so we have not to care about architecture. We have to basically understand what is there inside this particular folder list. For example, slash a is there, so you just mark it over here, right? Now since slash a is over there, because so all the folders inside slash a, if they are found in this particular folder list, they must be deleted, right? So here it's quite evident that this b is so basically there is this folder as well, abc, which exists in this folder list, and there is abd, which also exists in the folder list. So since these are subfolders of slash a, okay, so I got it. So earlier I mistakenly drawn a wrong conclusion, which earlier I said, like, if there is a and then there is b, then there is c, then there is d, then there is e. So earlier I said that e is a subfolder of d only, not c, but that is not true. Basically, obviously, inside c we have d, and inside d we have e. So e is basically a subfolder of all the parents above it. So it works like that. Cool. So now we are kind of sure about the logic. So what they did in this case, they did what they did, they remove all the folders of slash a if they exist in this particular array. So yeah, we just checked if ABC is a subfolder of A. It turns out it is. So we just removed it, and we just removed this. So what are we left with? We are left with this. And what is the explanation? So folders ABC and ABD will be removed because they are subfolders of slash A. Pretty much makes sense. Now let's move to the another example, and then we will be building our logic. So by now you all are kind of getting the gist of how we can solve this problem. Basically we have to check the parent folder, and in the list which we are given, this folder list, inside that we can remove all their children. Okay, now let's verify that logic in this example 3. So we have slash a slash b slash c. So let's draw it. Let me draw it with another color. Okay, so this is the root directory. There is slash a. Inside that we have slash b, and inside that we have slash c, and then we have slash ca. Okay, so it is at the level of b. After b we have ca, so we'll just draw like this, and then we have abd. So basically that is also at the same level. So this is the architecture. Again, I'm telling you, this is the architecture, the nodes, the basic, the trees, the folder which are there in the list can be different. Not all folders from here will be there. So this is the thing. So now we mark what is there in the folder list. All right. So we have ABC. So it means this particular folder is there in the list. We have to remove all its subfolders. So currently we don't have any subfolders, so nothing to remove over here. Then there is this CA. So we also haven't got any branching from this side, so it is also nothing to remove inside this. And we have ABD. So here also we got nothing to remove. So you see the exact same output is appearing over here. Okay, so pretty much what we drew from what is the, so basically if you see a problem, the first thing that should come in your mind should be the how we basically approach this problem. Forget about the time complexity, forget about whether it will fit in memory or not. Just you have to think, you are given this situation, how you can come out of it. So okay, so if we talk about that, so the basic understanding I'll write down. So this is how algorithms work. So you just write steps which you will take to solve this problem. So how can we solve this problem? So first we have to take each element in the folder list, right? And we have to find its children. So which is find children folders, which are basically subfolders. Find children folders for each folder. Okay, for each folder you find their children folders inside folder array, right? So inside this array, for a particular folder, at a time, you find what are its children's, and then simply delete them from the array, and that's the basic logic that will give you the answer array which we have to return, the output array. So you see, this is the very much simple logic to solve this problem. Now we will go with the worst solution, how we can go with this. So for that we will consider about these constraints later on. Okay, so first think about how you can identify basically if a particular folder is a children of a particular folder or not. So for that I'll just draw a basic example. Let's say we have slash a slash b, and then we have slash b slash c. Yeah, this is also possible. Yeah, and then you have slash a slash b slash c. Okay, This is very much simple example only. So, but yeah, it's here I want to highlight very important case. Here it's a/b/c. So you should not be looking at the names. What I mean here is you may think like this /b/c is a children of this particular folder, but no, you have to consider the architecture. So by architecture, what I mean, the first thing you see is relative to the root directory, which is the common line which by which it starts in a particular any directory architecture. So what will be this? So A will stand here, and if you see B, it will start in a different branch. So this is entirely different from this. Okay, and then you see A, B, C, then you need to go inside this. So A is matched here, then you have B, and then you have C over here. Okay, fair enough. Now let's come back to the logic which we were building. So what is the logic? The logic is we will start with this element. We started with this. So for that we choose the element, right? So we go to the next element. We are considering with this element right now. So now we spawn this. What is the second element? The next element is /b/c. You need to check if they are kind of related to each other. So for that, you just need to check if, so this is the main logic which I'm building here. So for this to be a subfolder of this, /a/b should be present in front of it. What do I mean? So let's say there was some particular string which is a subfolder of this. There should be /a/b. Wait, I'll write it here. So wait, just a second. Let me write it in a better way. So what are we going to do? First, we started with the index 0, which was /a/b, right? So what is our quest? So we are looking for the strings that are in this left remaining array, which starts with /a/b, and then there is some other stuff. This could be variable, but yeah, this should be there in front of it, right? Then it's a subfolder of the this folder. Like I told you earlier, since this is the root directory, then you have A, and then you have B, and then you have C, and then if you have D, so the children, the subfolders of B will start with /a/b. So this C will start with like A, B, C. Its path will be this. This D will have its path as /a/b/c/d. So yeah, so what is common? So the common thing is for the children of this will itself be /a/b. So for children of this particular part should be present at the beginning of the string, right? So in this case, what we got? So we need to look. What we need to look? We need to look for all other strings. So this will be the template string, and others should match with it. So for all other strings, if they start with /a/b, then you have to remove it. And if they don't, skip them, do nothing, right? So by doing this, so let me just show you this. So this in action. So for this 0th element, we will be looking for, like in all other strings, these strings, for this string at index 1 we got /b/c. So it does not starts with /a/b, right? And then we came to the second string, which is /a/b/c, and you see, bingo, it starts with /a/b. So we just remove it. So we just delete this. All right, we just delete this. Same goes. So now we are left with after this step, we are left with /b/c. Now we continue our quest for this. So here what we will be looking for, so this is our folder list, which is sorry, there is one more element which was /a/b. Yeah, now we are considering the next element, which is the element at index 1, which is /b/c. What we need to do over here, we need to basically check in remaining string if they start with /b/c or not. So what is the remaining string? Basically, other than this string, we have this one, the element at 0th index, /a/b. So no, it does not starts with /a/b. So we do nothing, and now we are ended with our approach. Basically, for each folder, we are done with this execution, and we all have also deleted them. So what we are left with is this result is the final answer. So this is quite very much a simple logic. What we do is basically, now let's talk about talk about all of this in a language of code, right? I'll just write it down, and then we will be making sense how we can fit it to the solution. Okay, let me just select this. If I delete it this way, it would be more better. Okay. Yeah, so let's write out algorithmically how we will be approaching this. So the step one is basically, so step one is for each folder in folders. So there is like, this should be actually folders, man. This folder naming does not make sense. Yeah, I'll change it in my code as well. Okay, so for each folder in folders, what we are going to do, so we will be identifying its so basically, let's say the string we get is the string we get is this folder string, which will be /a/b, this sort of string. So for each other folder, the remaining ones, we need to check, we need to match. So this will be other folder, which will be like /a/b/c. So we need to match the starting. So we will be matching starting, let's say starting string of other folder, it's same as the folder, this folder, right? So how we can check that? So we can check that, the worst way to check it will be one by one. So let's call this string x, let's call this string y. So we will check x of 0 if it's equal to x of y of 0, x of 1 if it's equal to y of 1. Yeah, so there are library methods which I'm not talking about here. So basically this will be a one by one check, and it will be a linear check, right? Yeah, and if you found this to be a children of that, you need to delete the node, delete the folder from the list. Now also from the folder array, whatever it is. Now the choice of data structure will matter a lot. Now, so this is the basic approach. This is the step 1, and this is the step 2. Oh, sorry, this is the step 2, and this is step 3. Right? So what will be the time complexity of this solution? So this checking is, by the way, this checking is order length of the string, and this movement in itself could go up to order n square, right? So basically for each folder you are kind of checking with each other element, right? Like let's say this is array, you got some strings over here, a b c d. For A you will be checking with B C D, for B you will be checking with A C D, for C you will be checking with A B D, so it will be n square, and checking itself takes this. So this solution is order n square into length of string. Let's see if it is a valid solution which satisfies the constraint. So okay, folder length, so the length of the array is 4 into 10 to the power 4. So Rn is it's very funny, Rn itself is 10 to the power, or in order 10 to the power 4, and length of str, the worst solution, could have its order up to 10 to the power 2. So this current solution is basically 10 to the power 8 into 10 to the power 2, 10 to the power 10. So it is kind of worst solution. This won't pass the complexity. Now we have to optimize our solution. How we can optimize it? First thing first, you should notice that you cannot afford this n square itself, right? Because it is 10 to the power 8, and we have to be under 10 to the power 7 at the worst level to pass the solution, right? So this will fail itself if you build a logic like this. Now what should we do? So what does that mean? If we cannot go in n square way, that means we cannot check for each element with each other element. We need to build some logic which is kind of robust enough, that does not needs to look like, you can do it if you're clever enough, you can do it uh, in order n only. And now here comes the planning. Basically you need to extract some information which you are missing that could reduce this time complexity. So what I'll do here is the intuition which comes to my mind will be to look at the architecture. I'll start building an architecture. From there I can deduce something, right? So I'll start building architectures, right? So by that we can make some kind of network or something, right? Yeah, that can be done, right? So let's say this A could be like slash x slash y. This B could be, let's say, slash x slash y slash g. Now what can we do over here is basically, let me think. So when we are at A, we get these strings, right? So we can create a particular tree, right? That architecture tree I'm talking about, okay? So how can we create this tree? Yeah, we don't forget about the tree. We can create something which is so we can store things in a hierarchical manner. One thing that is coming to my mind is basically sort this entire structure. What will that do? It will basically sort everything. Like let's say if there is slash x, it will do make it like this, slash x slash y. Then you will have I think that will be there. Yeah, then we have slash x slash g, like that. Yeah, okay. What is this ensuring? Like then we can get slash x, like slash x slash y slash g. Let's say do that, and then we can get slash x slash x slash y slash z slash t. What? So let's say if this is sorted, then in that case we can create an index. So we can create a structure basically. So if slash x is the new node, we can create slash x over here like this. and then the moment we get here, we get slash x, so we pick up this, and then we pick up what is the next one, then there is slash y. So this is slash x slash y, and then there is slash x slash y slash z, which means one more level down. So this will be this will be slash x slash y slash g. Let's call this slash g. Okay, so main aim is to identify this particular thing. So if you have sorted it, it is guaranteed that the children of it will lie after this. That should be pretty much evident, right? Because you have sorted it. So by sorting, what does sorting means? Because they will be alphabetically sorted. So there can be slash x, and if we have slash x slash something or whatever it is, in that case it will be just after this. So slash x slash y, it will come after that, right? And obviously slash x slash a comes before this, slash x slash g comes after that. But if you have slash x slash y slash a, it will come after this only. So very much simple approach. If you have to kind of cache this thing. Let's say you put this in a set of strings, set of like file location object, right? And you put it here. If it is not already existing, you just put it here. And now for each one of these, you have to check. What you have to check, you have to take slash x first. You check if it exists over there. If it does, then you have to just delete this node. If it does not, in that case, what you have to do, in that case you have to take the next chunk, which is slash x slash y, and you check if it's there. If it's yes, then delete. If it's not, and since you are at the end of this, you will be pushing this to the set. Yeah. And how will it be efficient? Let me tell you. So first thing first, you will be making the sort operation, which sorts the array based on the strings inside it. So yeah, we might need to write our own custom functions which will facilitate it. So this could go up to n log n, and here n will not be 10 to the power 4, it will be 10 to the power 4, which is the length of the array multiplied with the length of the strings, which is 100. So it will be 10 to the power 6 log n, which is affordable, right? So it is affordable. Then you have to maintain a set. This set will store a set of strings. So normally set operations are log n. N is the length of the string. N is the length of the set. Here it will be log 10 to the power 2 multiplied with 10 to the power 4. It can go up to this order. So this is also affordable, right? And then at the end, what will we do? We need to remove from the array. So this itself is an order n operation if we choose an array. For that we need some flexible data structure which can allow us to remove the nodes. Alright. Oh, okay, so don't need to worry about this. Actually, by the end of this, you will be left behind with a set which is your answer already. Because set, what does it store? It stores the parent folders only. The children we delete by checking inside the set. That makes sense. So yeah, this will be the answer. We just convert it to a particularly a vector and then return it. So I hope we are clear with this. Guys, we are clear with this. Are we? I'll just quickly check if any one of you are watching this stream. But I'm not live. Oh, I'm live. Okay, so we have got a visitor. So I hope we are. All right. Okay, let's code it up quickly. Okay, so I won't take much time in this. Basically, if I solve it myself, if I solve these problems myself, I do it very fast manner. But since now I'm iterating with all you all, it is taking a bit time. So I am quite confident about this approach. But here we have got some hurdles. What are the hurdles? They are hurdles based on the language, based on the language limitations, and basically you have to figure out how you can basically do stuff. Okay, how you can basically sort the things like that and stuff. Oh, so by that I got a good idea. What is that idea? So basically we don't need to sort things, we just put uh, put the strings in a set itself. What do I mean? So this will basically sort it by default, and then yes, after sorting it we need to iterate it, so we may need to create a copy. So this will sort it by default, right? And yes, this will sort it by default and based on this logic only. So we just need to put the elements in the folders array to the set, and then you have to iterate in the set, and you have to maybe prepare some another set which kind of facilitates the check. So basically guys, the core logic of this is sorting kind of reduces this n square stuff which we were left with here, because by sorting what we notice is this pattern, that the subfolders will lie behind this only. Okay, so the subfolders will lie behind this only. That's the core logic. Okay, so now we can also modify this thing. So if you are noticing any element for the first time, you will be obviously pushing in the set. Yeah, this logic is also important. Basically this logic, I'm talking about it. uh, this logic. So first I'll write it in a more pseudocode manner. So this is the first step: push all strings to a set. Why? Because it sorts them. Now you have to, with second step, you have to make a copy. No, forget about it. Don't make a copy. I'll call this set particularly as folder set, right? And we in the next step, what we will do is uh, iterate in folder set. So in sets, there is one more thing, which is basically the order. When you iterate in the set, the order is sequential by default. So it is like the first string you get will be the parent only, if it is. So iterate in the set. So for particular string, which will be a folder string, right? We need to get inside it, and we need to extract the chunks. So let's say if this is /x/y/g, so we will start with /x first. We check, and we will have another set which will be the output set. Sorry, this has nothing to do with this iteration thing. There will be another data structure which will be output set. I'll call this basically parent set. But yeah, for here you just So what we need to do here is basically check if it is there. If yes, then do nothing. If it's not there, and skip other steps, right? Skip others. If it's no, then come to others. Then we got slash x. We will take slash y over here. So this will be slash y. You check for it. Okay, we check for this, and again, if it is a yes, then you just skip this part. And if it's a no, and then you'll go with slash x slash y slash g. And throughout you did not skip anything. So if it here also you check if it is a yes, skip. Otherwise, you will get out of this loop. Then what you will do, you will push this particular thing to the output set, which is the parent set. This one. And whatever the output set is your answer. You have to just convert output set to a vector. Why we have to convert to a vector? Because when I was writing this down, I looked at this particular thing. So the output which is desired is a vector of strings, so you have to convert it. Okay, so now it's quickly we have to just code it up. I hope this solution will work, and we'll come to this particular solution and refer to it if we are stuck. And obviously if we get something wrong, we might need to change our approach. But that's all okay. So right, so let's try writing the pseudocode for this. Let me just close this. No, not to close this. Let it be there. Okay, it's already paused. Okay, so first and foremost, we need the data structures. And what are the data structures? This is the first thing we need to do is to push all the strings in folders to a set folder set. Okay, so here I will be making a set of string which will be folder set, right? And then there is one more set which is the parent set. Now what we need to do, we just need to iterate inside this folder. So I'm using an auto iterator, which is basically a very easy way to iterate in any data structure if you don't need to care about the iterators and stuff. So here x is the default. By default it will return me the elements of the folder. Okay, so here what I will be doing here is basically I'll be pushing x into the folder set. So how we can insert, basically there is a method dot insert which which will insert these strings into the set. That's it, we are done with that. Now we have to iterate in the set. How we can iterate? So again we need to do this. We will use this x auto iterators, and we will iterate in the folder set this time. And here x will be the folder string, so I can do like this also. So this will be basically a folder string, but let's keep it small, so let's keep it s, right? Okay, so now we need to identify this part, so we need to go with this particular logic over here, right? So this will be the thing we will be, I guess we will be iterating over here, and we have to grab the parts like slash x first, then we have to append slash y to it later on. Okay, so yeah, so there might be some conditions over here. Yeah, so the folder length, it will have at least two elements, so there will be a slash. So basically this string, if I write a comment over here, this string will be of this type. There will be a slash and some character over here, like let's say we call it z or something. This is sure to exist. Okay, so what we can do, we can make a temporary string. Let's call this temporary string, and there's a method substr which grabs a substring of the string. So we can do like this. But we need to be careful about it, right? Hmm. So here we will be pushing two characters. So this will the first thing, the first input, first parameter will take the index from where you want to grab the substring. So I specified the 0th index, and the next is how many characters. So basically two characters, 0 and G. Right, so this will be our starting point. I'll quickly tell you how it is our starting point. Now we just iterate inside the string. Let me declare a variable n, which is the size of the string, which is like this. And we just iterate inside the this particular string. And the catch is, let me just change this I to 2 because we have already grabbed till the first index. Now there are two conditions. If the character which we have over here, I'll call this s I, if it is equal to this slash, then whatever we have built inside this stem, so let me just fix this. We need the type definitions, obviously. So if this character is that, in that case what we need to do, whatever we have captured till now is basically should be checked. This logic will hit. So basically, since we are getting this particular slash at the moment, that means that we have already grabbed slash x inside temp. Okay, so in that case, we need to check if it is in the output string, in the parent string, which we will be parent set, which we will be returning at the end. So here comes the check. If st, sorry, with parent set dot find, what we are going to find, we are going to find the temp string is not equal to um, parent set dot is not equal to parent set dot end. So basically end is the iterator that exists beyond the set limits. So if you find out this temp thing and you got no matches, by default the this function will returns the end iterator. So if it is not equal to end, it means it is there in the set, right? So if it is there in the set, what you have to do, you have to just skip this part. You have to just continue, move with the okay, so we got something here. If we continue from here, it will skip this loop, but we want to skip this particular loop. So what we can do here is basically we can do make a variable over here, like it will be a boolean variable like stop, which is false initially. And here what we will do here is basically set stop to true, and at the end of this loop, and after that we break from this loop, and after breaking from here we just check if stop is true. You have to continue, you don't have to continue any further, right? Otherwise you need to push otherwise you need to push the particular temp string to the parent string, which is the parent set, not string, parent set dot insert this temp string. Okay, so this was basically, if you found this slash, it means that you are at a particular subpath and you need to check if it already exists in the parent set. Okay, so if it doesn't, then you need to check one more thing over here. So nothing to worry about this here because it's a slash. It means there are more characters after this, because you already have seen this. They've already specified um, this kind of path cannot be valid. Okay, so I hope all the not I hope, I need to be sure, by the way. I need to be sure, like strings like this don't exist. Okay, so format of the path is one. Yeah, so if they are saying like it will follow the format, I don't think we need to worry about that. Okay, so what does that mean? Basically, when you encounter this character, after that it is sure to have one character. So it means this is not the end of the string, right? So in that case, what we need to do in the else thing, we just need to push the we need to push back. So strings also, string methods are more like vectors. So we need to push back this particular string and this particular character to the string, temp string, and it will follow the next uh, elements, right? Now what is the next thing? If it is not slash, then you need to check if you are at the end of the if you are at the end of the string. So I'll just call if else over here. So else if I'll just here check if I is equal to n minus 1. In that case, we need to check whatever the temp string we have. So if it is the last character, so first we need to push this character, and then we just need to execute this logic, right? And if it's like if it is not there in the parent, we will be automatically pushing it over here in the parent, right? And one more thing is there is so yeah, we can do this. Basically we can break after this part. Yeah, so why we are breaking from here? Because if we don't break, and here I was about to write this temp dot pushback. This is basically the flow logic. We will be pushing the current character to the string. And if we don't break over here, since we have already pushed si, and it will push si once again, which will basically make trouble for this one. Yeah, and now the final thing is basically we have to convert the particular for parent set to the parent set to a vector, and then we can return the answer, right? So I'll just call it vector of string, and it will be answer string. And what we can do here is for auto x inside parent set, parent set, I just need to push this. And since we return the answer in any order, the folder order doesn't matter, right? Folder order doesn't matter. So here what I'll do, I'll just push this x over here. And yeah, we are done with this. Mostly yes. Yes, we're done with it. So we just push, this will be pushed back, and we just return the answer. Does that make sense? Yes, I think I'm done with the solution. Let me check it how we. It is quite short, to be honest. The code is not too big like we solved the previous problems. Okay, so we are missing a semicolon. Then we can run this once again. I hope everything is correct. Okay. Oh, so there the answer is correct, but we got some kind of I can understand from where it comes. So we are pushing this thing over here, which we don't need to push because at the end we are anyway pushing it here. Cool. Let me run this again. So guys, it has passed the initial test cases, but obviously it's not a complete solution until it passes all test cases. So let me check the performance of it. Pretty much impressive, man. Like it was able to kind of work. Basically I was most unsure about the thing, like how we whether these data structure will be able to handle the logic which we have built over here. Yeah. but they were able to. Yeah, so that is a big thing. Basically, when you start coding, you should be first aware of all the methods that exist, right? So this came into my mind that put all the strings to a set, because I knew, like, when we store strings to a set, they're automatically sorted. Yeah. So now what I'll try to do, I'll just try to put my own test case. So this is kind of for the self check. Even if Leetcode doesn't tell me it's true or not, I can verify it on my own, like if it is a good solution. So let me just write my own test case. So I'll be just telling here slash x first. Oh, I think there was a test case like that previously. Yeah, this test case was that only. All right, but yeah, this was kind of sorted in itself. I'll try to make it. I'll try to make it unsorted and check if that works, right? So it is not sorted because you see, slash a should come before this. That will basically test the set thing. So guys, it is working. And what we got here, slash a and slash a. Yes, now let's click over here and let's see what happens. If we get a wrong answer, we will just debug it. Okay, so guys, it's a success. We have solved this. Now talking about the logic overall. So I'll be explaining the code once again. So there's nothing to explain in the code. I'll explain this logic only, right? So how we are basically solving this problem. So what are we doing at the first step? Pushing all the strings to a set, folder set. Why? That will give us a string of this order, which lets us do this. By the architecture we know, like if we sort these particular strings in an order, by architecture we know, like the children of slash a will come after that, after this particular string, after this particular index they will come. Like if there is slash a slash b, it will come just after this, right? So whatever comes, so if we have sorted, so what can we do? We can just progress in one loop, and in one loop we can keep track. Basically, what was the problem with previous approach? There we had to check with each and every element, like in this thing here. Let me, so all of them are sorted only. Okay, so if it was not sorted, in that case it might be that before this slash a we got here, like let's say we might get, like, let's, before this slash a slash b slash c, we can get slash a slash b, right? Slash a slash b. So when we are examining this particular node, we may need to go back. Pretty much I think it makes sense. Yeah, basically that's very simple thing. So when you sort it, the children of this, the subfolder of this particular folder will appear after this only. So what we can do, we can just push this folder over there. We can push this folder to a set. Why set? Because sets allow you to check in order, log, and time, right? So checking is also not order n over here, right? So you push this in a set, and set will tell you, like in order, log, and time, that if this particular thing exists in the set or not. So when I come to their children, as I told you, I start with from the start. So I will check if slash a is there in the set, and it turns out it is there in the set. It means that whatever comes behind this is a subfolder, and by the rules we have to remove all subfolders. So we have to remove this thing, right? So we will remove this thing from our folder set, but we didn't need to remove it, because what we were building, when we were building parent set, that is our answer itself, right? Now we came to this slash a slash b slash t. So here also, when we checked for slash a, it was found in the parent set, and there only we exited. Okay, and then we don't need to check the other stuff. So that's how the code is working. Let's see it once again. So this is the folder set and this is the parent set, right? So first step was to push everything in the folder set to the everything in this folder vector to the folder set. This will, what will this do? This will basically, let me write it. This will basically sort strings in a order, right? In C++, sets do sort the strings. It is not like map or something. When you iterate inside a set, it will it will have strings in a sorted order, right? Which fulfills our test, which fulfills our requirement, right? And then there is this second step for each string in the folder set. So now we are iterating inside the folder set, which is kind of sorted. So the first element is there. So now what we did, we took the first two strings to start with, and we maintained a temp variable, and then we started moving with the another. So we are currently examining this. So what we are doing, so we are examining this particularly for the first time. So what we did, we pushed slash a to the temp string, and we are executing this logic. So if we have covered this particular path, what we will do, so in this case, for the first case, yeah, we have covered it. So what you will get over there, so the length, the n will be 2 in this case. So in that case, this will not execute, and we just directly come to this part. So stop will be false here. So we will not execute this. We will just push slash a to the parent set. Now we come to this slash a slash b slash c. So here we again took the slash a part in temp, and what we did next was basically when we encountered slash, so here now we are moving with I equals to 2. So 2 means 0 1 2. We are moving with this particular thing. So we encountered a slash over here. We check if it is in parent set. So we check if temp. So what was temp? So temp was this string, right? So we checked if slash a is there in the parent set. It is. So yeah, we kind of break the logic, break this particular loop, and then and after breaking this, we move ahead with the another string. Likewise, you at the end you will be having your parent set, which is your answer. And here I have just converted it to a vector. Why? Because we had to return it in a vector of string. Yeah, that was the approach, and I hope you guys understood the problem. Mhm. Memory wise, it's efficient, and runtime wise, it's also good. It's not bad solution, I would say. Why? Because I don't think you can do it without sorting. You can do it without sorting. Maybe you need to create graphs. That is also a thing. Basically, you make trees, right? We make trees, and you make n trees, like n trees, and yeah, that is also a good approach. Yeah, I liked it. So basically, one more idea is coming in my mind, and that is about creating a tree. And basically, that is the same thing. The entire thing lies in you understanding this particular thing, which we call it the architecture of a folder. That is very much important. And yes, so the tree thing, how it will come into action. Let's say you have slash x slash y, and you have this, and then you have, and let's say you got slash x slash y slash g slash w. So how will it come to action? It will come to action in this way. Yeah, I don't know whether that will be efficient or not. So, but I'm discussing it right here. So, what will you do? We will just create a, you will just create a root node, which will be the root directory. Let's say you spotted this. So, what you will do? You will just create branches x, y, then you have G, and then you have W. Here you have X and Y, so this is there only. So you got one element over here and you got one element over here, and then you have this X, Y, Z over here. So this will be X, then there will be Y, and then there will be Z. Oh, sorry guys, my bad. So X, Y, Z is already taken care. Now let's say we have A, Y, Z. In that case, we have A over here, so we just put A here, then we put Y here. I wanted to take this, but I mistakenly put X over here. So yeah, this will be A, Y, G, right? You see these two? So now you'll mark a star over here, right? And how you'll return the answer. So creating this tree is not difficult. How you'll return the answer? You'll return the answer like this. Basically, you'll start going down in the tree, and once you spot a node which you have already marked, you just push it to the answer folder array and skip the remaining part, you know. And here also you just skip the, you came here, you just push the path which you have built, and you just skip the remaining one. Yeah, this approach is very much better, I guess, because here we will be doing all of this. Creating this tree is a bit challenge, I would say. No, it's not a challenge. It's not a challenge, but more it's a game of caching, by the way. Not caching, it's a game of indexing. Yeah, basically the node values. I think I'm very much fascinated with this solution, man. Like this tree approach is very good. How it is good? Because you will be creating a tree, and the leaf nodes will be the leaf nodes will be your answer, which you don't need to. Hmm. I think there is some anomaly. Yeah, there is also some catch. There is also some catch. Let's say if you're preparing X, Y, Z, and W, and you got another branching here, T, P. Oh, I think it is good. Yeah, the main challenge here is basically creating this tree. You need to create it all the time. You need to create it. And obviously the leaf node will be the answer for sure. Yeah, this is also good approach, and if you want I can solve this in another video, but yeah, I think it's done for today. I hope you guys understood this approach, right? This is a very much clean solution, to be honest. This tree thing, and that's the core thing basically. In our computer devices, the folders and everything, the underlying logic is a tree only. That's how tree data structures were created. Okay. Yeah, so I think we are done with the streaming. So yeah, guys, if you have any question or any suggestions, you can just computer devices, the folders and everything. You can just write in comments and let me know. Okay, bye. Let me know if you need the solution for the. Just put a comment down below and let me know if the solution for this tree approach. Okay. Yeah. That's it. Bye. Take care, and we'll meet tomorrow with the daily challenge.